Hello, welcome to my channel. I have been solving this past paper. Right now, I have this mathematics for paper 3, paper math 3, and it's from uh, June, June 2025. So, we have already done several questions. So, let's jump on to question number 9, I believe. Uh, 8, question number 8. Okay, we have done the 7 questions in the previous videos. Okay, so here we are given a differential equation. What is the differential equation? This contains derivative of some variable. So you can see that we have a differential equation. Okay, and this is our initial or boundary condition we call it, and we have solved the equation. You see, when we have an algebraic equation, the solution of an algebraic equation is a constant. And when you substitute that constant back into the equation, it satisfies the equation. That confirms that this is the right solution. But the solution of a differential equation is a function. So here we see the derivative of x here, right? So the solution of this equation will be a function of x. Okay, so this is what we are looking for. Okay, so how will we approach this one? What we will do, we okay, this is sine 2 theta into dx by d theta equals 4x plus 3 into cos 2 theta. So we will separate the variables. On one side, I will have only x, and on the other side, we will I want to have theta. Okay, so I will do sine 2 theta by dx by theta equals 4x plus 3 into cos 2 theta in divided by sine 2 theta. Right? Okay, now what I will do, I will bring theta, d theta on the left side, so dx equals, and cos 2 theta over sine 2 theta into d theta, and I'll bring this part over here, so 4x plus 3. So you can see now on the left side I have only x, on the right side I have only theta. Okay, so next step I will integrate both expressions. The integral of dx over 4x plus 3 equals integral cos 2 theta over sine 2 theta d theta. Okay, you see, what is the derivative of 4x plus 3? It is 4. I have to 4 here, and I divide by 4. Similarly, sine 2 theta derivative is cos 2 theta into 2. So I want to have 2 over here and 1 over 2 over here. Okay, now we can see the derivative of the denominator lies in the numerator. So the answer is going to be 1 by 4 into next log of 4x plus 3. Similarly, on the right side, I have 1 by 2, and the derivative of sine 2 theta at this point is in the numerator. So it will be log of sine 2 theta plus a constant of integration, right? Okay, if I multiply everything by 4, it will be log 4x plus 3, and it will become 2 log sine 2 theta plus 4c. Now 4c is again a constant, so I can just call it a constant. Okay, I have to, okay, so it's log 4x plus 3, and this I can write as log sine square 2x, 2 theta. This 2 can go over here, right? Now if I bring it on the other side, left side will become log of 4x plus 3 minus log of this. So I can write it as log of 4x plus 3 divided by sine squared 2 theta. And this is a constant, right? Okay, now I want to change it from logarithm form to the exponential form. So if I take exponent on both sides, it will become 4x plus 3 equal sine square 2 theta, and it will become e to the power of c, which will become a constant, and g to the constant. Okay, so from here, 4x plus 3 is equal to a constant into sine square 2 theta. So I can write x equals c into sine square 2 theta and minus 3 and divided by 4. So it is 1 by 4 and multiplied by 1 by 4. So I can say x is equal to c over 4 will be constant. I'm just call constant into sine square 2 theta minus 3 by 4. I can move it to the 4 of 1 to the 4. Okay, so this is my solution. But now I have to incorporate the boundary condition. Or it's we have boundary condition. So when x is 0, theta is 5 by 12. Okay, so what is it? If x is 0, so theta is 5 by 12. Okay, so let's put this condition into this equation. So x is 0 when theta sine square 2 times theta is 5 by 12. So using this condition, we can evaluate the value of this constant c. Okay, you see, 5 by 12 times 2 is 5 by 6, 5 by 6 is 30 degrees, 30 degrees times 1 by 2, and 1 by 2 is square 1 by 4. On the right side, I have c by 4 minus 3 by 4. So from here you can see, and here I have 0. So from here you can see that c is equal to 3. Okay, so when I substitute this value over here, so x equals 3 times sine square 2 theta minus 3 by 4. So this is our final solution. Okay, I hope you understand every step and the logic behind every step. Okay, question number 9. With respect to the origin O, the points A, B, and C have the position vector given by the equation. Okay, so find a vector equation for the line through AB. So imagine this is my point A and this is some point B. So we are given the position vector of A, position vector of B from origin. So I know this vector and I know this vector, right? So I will try to find this vector first of all. So you see, this is origin O. So OA plus AB is equal to OB. So from here you can see that AB is OB minus OA. Okay, what is OB? It is minus 2, 1, and 3. Minus OA, it is 1, minus 4, 2. Okay, so 2 minus 1 is minus 3. 1 plus 4 is 5. 3 minus 2 is 1. Okay, so 3, 5, minus 3, 5, and 1. Okay, now imagine if all the points on this line, right? How can I write the position vector of each or any one of them? So, okay, so that position vector, it is position vector of A, so OA plus some constant times AB. So this constant varies. It's 1 minus 4 and 2 and plus some number times AB, which is minus 2, 5 and 1. So this is the expression. This is the reference equation for the line to AB. Okay, my understand. Using a scalar product, find the exact value angle or the cos of BAC. Okay, so let's assume again we have 3 points A, B, and C, right? So we need to find the cosine of the angle between this angle, right? BAC. Okay. You see, if I talk about the dot A dot AC, right? AB dot AC. So you know that the magnitude of the magnitude into of the cosine B, right? Okay. So from this is equal to A dot AC and divide the magnitude AB times magnitude. Okay. So first of all, AB vector is found and that minus 3, 5, 1. Minus 3, 5, and 1. Similarly, we can find AC and how we find it is the C vector, which is 2, 3, 5, minus A vector, which is 1 minus 4, 1 minus 4 and 2, and this will be 2 minus 1, 1, 3 plus 4 is 7, and 5 minus 2 is 3. Right? Okay, so now we are ready to find the dot product of AB and AC. And I hope you know that dot product will be the A part, all three complex multiples of so minus 3 times 1 is minus 3, then 5 times 7 is 35, and then 1 times 3 plus 3. Okay, now what is the magnitude of AB? The magnitude of AB is 3 square is 5 square is 25, and 1 square is 1. And multiplied by AC, so that is 1 plus 49 plus 9. I have your following at each step. So this would be 35 and divided by this is time to come and this is 35 there, and this is 59. Okay, and of course 35 into 35 it will become 35 over 59 hundred. Okay, so this is the cosine of BAC. Okay, I hope it's clear. Find the exact area of triangle ABC. Okay, again, I will make this triangle. Let's say this is B, A, and C, and we need to find its area. So BAC, so we know the triangle, B is also the triangle, and we know we have this cosine, right? Okay, so let's assume this perpendicular, whatever it is, right? So the area of this triangle is into base. Base is AC. In fact, it is AC, right? And this is on B. So what is this? BD, right? Again, you can call it. Okay. So how we will find this working? It's 1/2. AC, we know the value of AC. The magnitude of AC was 59 under the root. So this is under the root 59. Right? Okay. Now BD. BD that we can put over here. This BD then, this is equal to AB into sine of BAC. Right? BAC angle is sine, what is angle BD then. Okay. Now AB is also AC. We have known AB value. The magnitude of AB is what? 35, right? It is under the root 35. Okay. Now, how do we find the sine of BAC? Right? Okay. Imagine if I have a triangle and the cosine is, how much was the cosine we found before? 35 over 59. So this is 35 under root and this is 59 under the root, right? So if these two are, if the measure of these two, then the cosine of this angle is going to be 35 over 59. Okay, but if this is the case, can we find the length of this side? So using Pythagoras theorem, square of this thing is 59 minus square of this thing is 35, and we need to know the under root, square root of this one. So this will be 24 under the root, am I right? Yeah. Okay, so it means sine of this angle. Okay, in fact, this is A. Okay, so sine of this angle would be 24 over 59 under the root. Okay, I have it clear. So sine of AC would be under the root 24 over 59. Okay, so let's substitute this value over here. For BD, we have 35 under the root and then 24 under the root and divided by 59. So 59 cancel and my answer is going to be half, and under the root 35 times 24. Okay, so from 24 if I take 6 into 4, so 4 comes out, becomes 2, it cancels, and I have 6 inside only, so 35 times 6 only. And this is 210 under the root 210. So this is the area of the triangle ABC whose position vectors were given to us. Okay, I hope you understand every step and the logic behind every step. If you ever have any questions, you can always ask me in the comment section. If you feel that these videos are helpful, then please subscribe my channel. Thank you for watching. See you in the next video.